Here in example 5 of lesson 6.1, we're asked to find the quotient of this expression. And this is going to work out similarly to what we did when we were trying to get radicals out of the denominator. One of the rules of mathematics is that we do not want to leave an I in the denominator of a fraction. That's just against the rules. So what we'll do is something similar to what we did with radicals. We'll multiply by the conjugate of what's in the denominator. So what's in the denominator here is 4 minus 7i. So the conjugate of that is 4 plus 7i. We're going to see how that magically allows us to eliminate the i's in the denominator. And of course, by multiplying the numerator by the same quantity, it's just like we're multiplying by 1. So on top, what we'll do is we'll go ahead and FOIL. First times first will give us 8. Outside times outside will give us 14i. Inside times inside will be minus 12i. And last times last will be minus 21i squared. In the denominator, first times first will give us 16. What happens is, when they're conjugates, like with radicals, the outside product, in this case 28i, and the inside product, in this case negative 28i, will always cancel one another out. So we just have to do the first times first and the last times last when they're conjugates. So last times last will be negative 7i times positive 7i, which gives us negative 49i squared. Now I squared, we remember, is the square root of negative 1 times the square root of negative 1. And whenever you multiply a square root by another square root, you get just the number underneath the radical. So that's equal to, in this case, in all cases, negative 1. So this is going to change to negative 21 times negative 1, and this is going to change to negative 49 times negative 1. So now if we go further with this, we have some i's here on the top. 14i minus 12i is 2i. And then we have some real numbers here on the top as well. We have 8, and then negative 21 times negative 1 is positive 21. So we have 8 plus 21, which is 29. And then our i's turn out to be equal to 14i minus 12i is 2i. On the bottom of our fraction, we have 16, and then we have negative 49 times negative 1, which is positive 49. So 16 and positive 49 add up to 65. So our answer here at this point is 29 plus 2i all over 65. Now it would also be acceptable to write these as two separate fractions. 29 over 65, which doesn't reduce, plus 2 over 65 times I.